Welcome to our NPTEL lecture on advanced power electronics and control. So, we shall continue with our discussions on isolated DC to DC converter. We are discussing the forward converter. Let us go to the operation of the forward converter. The switching frequency is same as that of the flyback converter, is generally kept high and such that the next switching takes place before inductor current decays to 0. We want as a continuous conduction mode. For simplifying analysis, we have already discussed that on state all the conditions of ideal is considered. That is, that drop across the two diodes is assumed to be 0. Switches turn on and turn off of the switches is lossless, and conduction loss of the switches is also 0. These are actually the leakage current through the devices in offstate is assumed to be 0. Transformer used in the circuit is assumed to be ideal and coupling is 100% with no magnetizing current, no leakage inductance and no losses. All the filters element that mean inductor and a capacitor are assumed to be lossless. The input and the output DC voltage are assumed to be constant and ripple free. All the analysis is done considering circuit in the steady state condition. So, see that this is the switch and you have to control this output voltage irrespective of the load. Load may change, but output voltage required to be maintained constant. So, what happen if you couple equivalent and this circuit is been shorted and transformer will transfer power to the primary to the secondary, and essentially you couple the whole element here and that boils down to this part of the circuits. Refer these things into this part of the circuit is referred to the secondary. So, we know that actually referring the circuit in the primary and the secondary of the transformer, we have referred this circuit into the secondary, and thus you get Ns by Np into EDC. So, this is the effective DC bus voltage and this part of the filters come into the picture, and of course, you can use T filter sometime, pi filter also, some kind of filter may be used to get a better results, because you have a here 40 dB decay, you can increase that decay further. It starts when switch S is on. So, the input voltage EDC is connected to the primary winding. Both primary and the secondary winding starts conducting at the same time when switch S is on. Primary and secondary currents and voltage are calculated by considering the trans ratio Np by Ns as an ideal transformer. When S is closed, D1 in secondary circuit is forward biased and secondary winding voltage is scaled down by the ratio of Np by Ns. Diode D2 remains reverse bias in this mode. So, because energy is flowing for primary to secondary. And from this equivalent circuit, it is clear that during the mode 1 condition, voltage across the LC and the load voltage is EDC Ns by Np. So, it is just like a step down transformer, DC step down transformer. So, EDC Np by Ns is the maximum voltage across the load, considering that duty ratio equal to 1. So, you will get lesser the voltage than this value. The mode 1 is called the powering mode, as the input power is transferred to the source to the load. And next comes to the second, when this switch is off and thus D1 is off, ultimately this portion of the circuits plays, and we assume that this D2 is ideal, that it can be shorted. So, you get this part of the circuit to be actually constituted and the feeding to the load. So, this is the oscillations of the network. So, when AC is turned off, primary and the secondary winding current of the transformer becomes 0, but secondary side filter inductor maintains continuous current through a freewheeling diode D2. D1 is reverse biased. So, thus this bucking operation comes into the picture apart from the trans ratio bucking. D1 is reverse biased during the mode and input is isolated from the output. Inductor current flows through the parallel combination of the load and the output capacitor. During this mode, there is no power flow from the source to the load, but output voltage is maintained constant due to large capacitor. A charged inductor and the capacitor is used in the circuit. It provides continuity in the load voltage, but in this mode there is no input power involvement. Capacitor voltage and the inductor current start decreasing while feeding the load. Therefore, to maintain continuity in the output voltage, AC is turned on again. Mode 2, to maintain the load voltage within a desired tolerance band, the filter inductor and the filter capacitor value should be chosen sufficiently large, but it should not be that much big or bulky that it will be costlier, bulkier, weightier, everything that can increase the cost size of the filter. So, design has to put a proper step to design this isolated DC to DC, this type of isolated DC to DC converter. All the design should be at a high frequency to reduce the size of the filter circuits. Generally, we can go up to a level of 1 kilowatt with that, and switching frequencies typically of this converter we can choose MOSFET to have 100 kilohertz switching frequency. Now, what are the advantage of this forward converter type SMPS over flyback? Advantage with respect to flyback: better transformer utilizations. Forward converter transformer transfers energy instantaneously across the transformer and does not actually store the energy. The resulting lower peak current in the primary as well as the secondary means lower copper losses compared to the flyback. The transformer can be made with a more ideal with such higher magnetic inductance and no air gap. Filter output energy stored is mainly in the output inductor, and the output capacitor can be made fairly small with a much lower ripple rating. The output inductor and freewheeling diode keeps the output current fairly constant, and the secondary ripple current is dramatically reduced, and its main process is to reduce the output voltage ripple. That is the whole purpose of it. Due to much larger magnetizing inductance, lower active, so that actually the current is less peaky than this flyback converter. So, this is one of the advantage of this forward converter. Disadvantage, you have a more component counts. It increases cost, the additional output electrical device and the freewheeling diode is needed. Please note that since you are operating at a very high switching frequency, this diode required to be a very fast recovery diode, and for this reason it adds to the considerable cost to the bill of material. Minimum load requirement, that is also a feature. You cannot keep your load open circuited. Significantly, with the multiple outputs, the gain dramatically changes if the devices goes to DCM operation at light loads. Higher voltage demand for MOSFET, which frequently discourages the use of line applications that has got to work on 230 volt grids. So, these are few things we have to keep in mind. Now, let us go back to the another converter. Essentially, you couple one of the disadvantage of this actually isolated DC to DC converter, which we have discussed, is that we require to reset the flux, and to reset the flux we have a constraint of the duty cycle. And ultimately what happens then, you have to feed power from the stored energy. In flyback, when switch is on, no power flows, ultimately energy flies back, and thus power handling capability is less. And we cannot increase the duty cycle beyond 50%, because then what happens, resetting of the flux is a very big pain, otherwise the magnetics will saturate. Same in case of the forward converter, if you increase the duty cycle beyond some limits, so resetting the flux is also a challenge. So, for this reason we require to, because we have always told you that actually we have solved few problem in forward converter, because stresses across the switches here, it is quite low, because you do not have once actually previously what used to happen, once it is switch off. So, since there is no voltage across it, so it is just blocking the voltage of VDC. It is not blocking the voltage VDC plus NP by NS into V0. So, stress across the switch got reduced, but resetting have the winding has to be ensured by smaller duty cycle, and thus power rating of the devices become lower. So, these are the few challenges which we wanted to remove in case of the push pull converter, where actually we can think of that one push pull converter in actually one forward converter forward mode, and another forward converter on off period, which has been actually put together in parallel to give the more power. Essentially, it will have a more power rating, and you can see that this is component count is also increased. It has the 2 switches, but we will see that what are the actually the voltages across the switch, and accordingly we will see the devices. Now, you see that these are the pulses of switch 1, this, and this is the pulses of switch 2, and that required to be separated by a small time duration. And once actually, since there is a inductance in the circuit, so there will be a spikes. So, this voltage is the VDC1, and this is the voltage stress across the switch Q1, and it will be blocking that voltage. Still it is conducting, then it will be a voltage of V in plus the stance ratio of NP by NS. So, they will has to block. Once this actually Q2 is off, so voltage will come down to the level of VN, and then once it is re-triggered, it will come down to the 0. Same way we can have a replica of it which had not been shown. So, this is the D2. So, we assume that this switch is blocking that voltage since it start conducting initially. So, this value is VN, and thereafter this is basically NP1 into S1 into V0. So, this much of the voltage stress it has to block, then it has been triggered, and same cycle continues. So, this is the current in a continuous conduction mode for duty ratio for this devices, and Q1 is the current through the devices, and this is the current through the inductor IL, which will we have assumed that it has a quite steady load and current is continuous. Push pull converter is an isolated transformer. Isolated converter is a transformer isolated converter based on basic forward converter topology. It has been superimposed by the two basic topologies of the waveform are shown in the figure in previous slides. The high voltage DC is switched on to the central trap of primary by a transformer by switch Q1 and Q2 in an alternate cycle. Q1 and Q2 creates pulsating voltage at the transformer winding. Primary transformer is used to step down the voltage as well as the isolated output input. In push pull topology, there is a central trap of primary and the central trap at the secondary. Q1 and Q2 are given a pulses by the control circuit in such a way that it should create equal and opposite flux on a transformer core. So, you need not have to wait of the resetting winding to actually reset the fluxes of the transformer. So, there is no chance of the saturation of the transformer and you can take the duty cycle quite high level. So, let us talk about the first mode of operation. It starts with the turning on of the Q1. This is a mode 1. In the steady state operation, when Q1 is on, the dot ends become positive and D5 reverse biased and D6 becomes forward biased. Please refer to the figure, then only you can understand it better. So, Q1 is on, so current will flow like this, and ultimately this is the case of the figure. So, D6 becomes forward biased, therefore, the output load current IL flows through D6 and NS2 inductor and the capacitor. The input voltage is applied to the primary, scaled input voltage appeared into the secondary. So, divided by into by Ns. The voltage difference between secondary and the output voltage applied to the inductor L in forward direction. Therefore, inductor current value increases from L1 min to L1 max in subsequent time as shown in the waveform. Now, there will be a small pause between the conduction of Q1 and Q2, otherwise line short will occur. So, this small pause has been neglected. At the end of the T1 period, Q1 is switched off till time Ts, Q2 is turned on after half of the full time period Ts, that means at Ts by 2 as shown in the waveform. When Q1 is off, body diode of the switch provides a path for the leakage energy to be flown, and if you use instead of the MOSFET for the other device, you have to give anti-parallel path for the diode, and the stored in winding 1 also the output filtered diode D5 gets forward biased. As D5 get forward biased, half of the inductor current of the N was flow through the D5 and another half of the inductor current of NS2 flow through D6. This results in equal and opposite voltage appear in secondary, assuming both the secondary have the same number of turns. Therefore, net voltage applied across the transformer secondary during T off period is 0. output voltage V0 is applied to the inductor L, reverses direction when both the switch are off. Thus, inductor current IL decreases linearly from L2 to L1. So, it will come back to the this thing. And now, voltage rating of the switch. During T on period, any of the switch that V in is applied half of the transformer of primary and equal voltage is included to the other part of the primary winding. Therefore, twice of the input voltage is applied to the half of the switch. So, switch used in push pull converter should be rated twice of the input voltage. As such, there is not much actual advantage of it. In practical cases, this voltage rating of the switches should be this percent more than the theoretical value for actually taking the factor of safety. So, we have the output input relationship across the switches. In the steady state condition, the output voltage can be V out equal to V in Ns by Np into 2D, where T equal to T on by T, where is the duty ratio. Now, what are the advantage of this type of push pull converter? One, resetting of the flux is easy. You need not have to, we have not shown, we require a compensating winding or the resetting winding in case of the flyback converter as well as the forward converter for resetting the flux, and thus voltage stress, that gives a voltage stress across the devices. So, for this reason, here it is automatically resets the flux in every cycle, and if it is a little adjustment is required, we can do by little change in the duty cycle. But that kind of facility is not available in case of the flyback converter, and thus you have been restricted to actually use your duty cycle less than 0.5. So, and hence power transfer primary to a secondary is quite lower. To drive MOSFET, push pull does not necessitate an isolated power supply. That is one of the biggest advantage of it. So, you can take the supply, you can actually same supply which you are taking as an input of the DC, there you can actually scale it down by maybe a small scaling resistance, and you can give the same power to the actually for the MOSFET driver chip. Peak current sensing is required so that core does not drift into the saturation. Push pull is used for far away access latch, releases cable and the security back cables. 7 volt 19 cables are extremely flexible and make them ideal for the assembling of this push pull converter. Push pull converter is of low cost, though it uses multiple switches, but you will find the rating of the switches is quite low and it can take more power than the forward and the flyback converter. Transformer rating require smaller than the forward converter, but only thing you have to keep in mind, you require extra switch. Push pull converter uses 2 switches which is not widely used in the flux walking phenomena. That means flux balancing can be done. Central tap transformer is used in one of the disadvantage of the push pull converter, because generally we do not manufacture central tap converter. So, now let us, now we have solved few problems, while in a first class on the DC to DC converter, I said that there are 3-4 challenges in DC to DC converter, isolated DC to DC converter. First challenge is resetting of the flux. In flyback you manage with the resetting winding, and thus you pay the price having huge stress across the switch, and also you restrict the duty cycle less than 50%, and thus what happen, you transfer less power from the primary to secondary, but it is a one switch phenomena. Forward converter no way better, but actually since you transfer the power from instead of the storing, so such of the basically electrical parameter gets better, because forward converter is more peaky. Forward converter's currents are less peaky than the flyback converter. So EMI, EMCs and all those other issues are there, where forward converter basically defeats the flyback converter. And in push pull converter, since the two switch topology, it resets the flux in every cycles, and stresses across the switch is just double of this DC bus voltage, and you can and you do not have any limitations of the duty cycle. So instead of actually this push pull converter, one of the disadvantage of the push pull converter that it's used the central trap transformer, and thus it required extra winding, and it is a bulky and costly. And there we go for the another topology, since it uses the two switches, it is the half bridge converter. Half bridge converter uses two switches, you have to give a DC blocking capacitor. What happens generally, this Q1 and Q2 may have a small difference of the time period. It may be as low as 1% deviation or 2% deviation, but 1% or the 2% deviations into this switching may lead to the saturation of the transformer. So DC blocking transformer required to give a DC blocking capacitor required to keep, so that what happen, this core does not get saturated. And we shall see that stress across the switches and all those issues here, and we will find it is better off than the push pull converter. So this is the pulses and for the switch Q1, and this is the pulses of switch Q2. You can see that this is the primary voltage across this transformer, and it is Vp, and which is half of the voltage of the DC link voltage. Since actually Q1 is triggered, current is flowing through this, and ultimately this point is blocking the half of the voltage. So voltage rating of the switch is just V in by 2. Similarly, once actually you got a negative cycle also. So you got a positive voltage cycles and negative voltage cycles. When actually Q2 is triggered, automatically flux gets adjusted. Unlike all the DC to DC converter we have discussed till now, we have not balanced the flux in that way by switching way, and here you have a chance to balance the flux balancing by really applying the negative voltage across this transformer and resetting the flux in every cycle, and so on. And this is the current across the switch. Once it is triggered, we assume that current is continuous conduction mode, and thus Q1 is actually current Q1 is actually going on. Thereafter, once Q2 is triggered, then IQ2 is going on, and so on. And you have the inductor current, that is L1 and L2, and it will be a superimpose of L1 and L2, and that gives you this kind of ripple current. So, this is the explanation of the half bridge converter, and it has a huge power handling capability, and since it uses 2 switches, voltage stress of these switches is half of the DC bus voltage, and all those advantage can be coupled into the system, and it can handle the power in the range of the hundreds of watts. So, this is the half bridge converter. We shall discuss about the half bridge converter in our next discussions. Thank you for your attention. Thank you.